Okay, this is Prakash Narayan. Good morning, good afternoon, good evening. Welcome to ATEA's webinar on AI/ML on AWS. First, a little bit about ATEA. ATEA is American Tamil Entrepreneurs Association, and it's primarily a business-focused, nonprofit 501c3 membership-based organization that fosters entrepreneurship among youth, women, and emerging business professionals. Even though it's American Tamil Entrepreneurs Association, we are not just serving the Tamil community, we expand to serve the Indian diaspora. And the focus of ATEA is to create a platform for exchanging business ideas, seeking mentorships and investments, making connections, and creating an atmosphere for entrepreneurial thinking. The theme, the motto of ATEA is link, learn, and lead. So we allow the linking through connections, meetups, and webinars. The learning obviously is through, again, these meetups and numerous opportunities, and leading through various leadership opportunities that we provide in the organization. We've been conducting this webinar series now. I think this is the 6th in the series. Ever since the shutdown began, so that there's an ability for people during the shutdown to be able to connect and learn in the process. So a few weeks back, we conducted a webinar on AI in action led by Girish Mukai. And that was primarily talking about how AI is used in the enterprise for application healing, for conversational chats, chatbots, etc. And during that webinar, we asked a question as to whether people would like to participate in a more hands-on, so how do you do it yourself session. And the resounding response was yes. So we approached the two speakers today. So let me talk about them. So the first speaker is Kunal Batra. He is a senior developer and technical advocate for AWS, where he helps drive awareness and adoption of their developer offerings. He has a focus on AI, and he's specifically on computer vision. And he's done several AI-related jobs in his career before he joined AWS. And the other speaker is Sashank Prasanna. He is an AI and machine learning developer advocate, again, working at AWS. So he focuses on helping engineers, developers, and data scientists solve machine learning problems. So we're really thrilled to have both Kunal and Shashank with us. So this webinar is being recorded, and that, by the way, is the calendar for the webinar series. So what we do is we post the recordings, the slides on the calendar so that you can come back and view them. And of course, future webinars. So typically we have these at 9 a.m. on Saturday mornings. So next Saturday, in fact, is another exciting webinar on COVID-19. We'll be publishing, we're going to have a physician and a clinician participate and help us understand COVID-19 from an unbiased perspective. So again, keep your eyes peeled on that calendar, and we'll be publishing it shortly. So with that, I'm going to hand it over to Kunal, who will be the first speaker. So Kunal, let me make you the presenter.
Thanks, Prakash. Let me go ahead and start sharing my screen. Okay, looks like it's sharing. Can you guys see that?
Yep.
Perfect. All right, let's begin. So my name is Kunal Batra. I'm a senior developer advocate here at AWS. And in this 30-minute session, we're going to be doing an overview of all the machine learning offerings and services here at AWS. It won't be all of it, but it'll be a big portion of that. So let's begin. Again, senior developer advocate here at AWS. I've worked on a lot of different developer-focused verticals. So if you have any questions on any of those, feel free to reach out at any point. The best way to get in touch with me is my Twitter handle at Kunal732, or you can email me, kbatra@amazon.com. And last, I'm really into machine learning and computer vision. Recently built an app for my family, lets them know whether the garage door is open or closed. Another one that counts how many people are in line at the Shake Shack at Madison Square Park. And then recently just built another object detection model over here that just tracks any household items I have just so I don't lose them. So this is my passion. This is what I'm doing in my free time as well. So if you have any questions on any of that, want to see the code or how to execute any of these things, please reach out to me. Okay, so the mission here we have at AWS is to put machine learning in the hands of all developers, whether that's data scientists or any developer without that doesn't have any machine learning expertise. And we look at machine learning here in 3 layers. So let's start from the top and go down to the bottom. That top layer here are AI services. These are services that we've created internally for Amazon.com, and we've opened up to our customers, or we've just directly built for our customers through AWS. These are all APIs that any developer can access. You don't need to have any machine learning expertise for these. And we're going to be talking about these towards the end of the presentation. Now, if you move one layer lower into that middle layer, these are our machine learning services. These are for developers as well as data scientists. These are services to help you build, train, and deploy your machine learning models, and these fall under our SageMaker umbrella of services. Now, if you look at that last layer, these are for our advanced machine learning practitioners. You can see on the left-hand side over there popular frameworks such as TensorFlow, MXNet, PyTorch. And we have teams dedicated to all of these frameworks to make sure that they run in an optimized fashion on AWS. And then from there, these advanced machine learning practitioners take advantage of whichever interface they want, any sort of infrastructure for training as well as inferences as well. So one thing to note over here is we are framework agnostic. We want you to choose whichever framework is right for your job. And then from there, you can run that fully managed on AWS through SageMaker, or you can run that yourself as well. And TensorFlow is really important here. I don't want this to sound salesy, but TensorFlow is something we take very seriously here. It's also 85% of all TensorFlow workloads run on the cloud in AWS. And so, like I mentioned, we have teams dedicated to all of these frameworks to make sure they run optimized in AWS. So for example, you can see stock TensorFlow over here has 65% scaling efficiency with 256 GPUs. And our optimized version that was compiled and fine-tuned for the AWS cloud has 90% scaling efficiency with 256 GPUs. And just to give you a little idea of what that means, you can train a ResNet 50 architecture with ImageNet in less than 15 minutes, which is quite fast. So to take advantage of these deep learning tools, you can use our deep learning AMIs if you want to spin up an EC2 instance right away and start training, or you can use our deep learning containers as well.
So Kunal, let me just stop you for a sec. So folks,
yes.
Our goal here is to make sure that you're following and to just have the efficiency of the webinar. We have you all on mute. So please pose questions. So for example, it's okay to pose, even if the assumption Kunal is making here is that all of us understand what TensorFlow and PyTorch are. If you don't, it's okay to ask, and Kunal can spend a 30-second overview of these frameworks. So please feel free to interrupt and ask questions. We want this to be interactive. Go ahead, Kunal.
Of course. So now we move up that stack. So sorry, we were before in the ML frameworks infrastructure. Now let's take a look at that middle level, the machine learning services. Now again, these services are for all developers as well as data scientists. This is part of our SageMaker suite of services. And again, SageMaker was created to help you build, train, and deploy your machine learning models. So in the next couple of slides, I'm going to go through some of the services that we provide under that SageMaker umbrella. So this slide over here is just showcasing a very simplistic view of that model building journey. You can see there's 3 phases broken out over here. There's actually multiple sub-phases as well. But over here, you can see that there's a data prep, model training, model inference. And one thing to note over here is that this is not, this linear fashion is not the typical model building journey. It's actually quite an iterative process, so much so that a lot of people I'm familiar with and colleagues refer to it as an art. The actual more accurate representation of this process looks something more like this. It's not straightforward. It's very iterative. You need to go back and forth to make sure that you are choosing the right hyperparameters, you have the right data, you're choosing the right algorithms to train your model. And so with SageMaker, we want to help simplify that journey. And one of the first services here that I'm going to talk about SageMaker is called Ground Truth. And when we spoke to our customers here at AWS, what they let us know is that over 80% of the time it takes to build and deploy a model actually comes in from that labeling phase. So with Ground Truth, we want to help simplify that process for our customers. So Ground Truth actually, it does 4 things here. It helps speed up that data annotation process. It gives you an access to human labelers to help annotate that data. It increases the accuracy, and we'll go over that in a couple of slides from now. And it also helps reduce the cost to label large data sets, which can get pretty costly. And so let's just start showcasing this. So the first thing to help your labelers to quickly annotate that data, we built labeling workflows. And over here, you can see on the left-hand side, these are some typical workflows that our customers have asked us about, and we built these to help speed up that labeling annotation process. So for example, if you're creating an object detection algorithm, it's easy to draw bounding boxes for that. It also is easy to choose categories if you were for image classification or text classification data sets. We also have workflows for semantic segmentation where your annotators can, by the pixel, showcase where an object is in an image. Right, so these are typical data sets that our customers have asked us that they want to get annotated. However, if one of those workflows doesn't exist, you can take advantage of one of our pre-made templates to get that data annotated, right? And I've seen this done with customers for audio classification, for example. So once you choose that workflow for your data set, the next thing you want to do is select the type, your pool of labelers. Who's going to label that data for you? You can take advantage of Mechanical Turk, which is a workforce of 500,000 strong workers to label that data. This is great for fast labeling if you have data sets that are not sensitive and you're looking for a lower price to get that data labeled. However, there are instances where you require specific subject matter expertise that Mechanical Turk can't provide, or you need you have data that's very sensitive and you don't want to make sure the public does not see that. In this case, you can choose a private workforce, and typically these are workers inside your own organization that have that subject matter expertise, or they can handle see that sensitive data. And then you also have the option to choose third-party vendors. These vendors also have their own sets of subject matter expertise that you can take advantage of. They also have different types of support plans that might be desirable for your organization for annotating that data. So now that you've got your workflow set up and you've chosen your pool of labelers who will annotate your data, the next thing we want to make sure is that that data is being labeled accurately. And so this is typically the part of the presentation, if this is in person, where I'll poll the audience right now and just ask them, what are you seeing? What type of dog breed are you seeing in this slide over here, right? And this is to showcase how a data labeler will annotate your data. So in this case, I typically get back 2 responses, either a bulldog or a Shar-Pei. And the actual answer is a Shar-Pei, but let's see what our example data labelers here annotate. So if we see the first one says bulldog, second Shar-Pei, third bulldog, fourth bulldog. So in this case, what we see a lot of our customers used to do prior hand with this majority voting, this would have been a bulldog, right? Which is not the correct answer. With ground truth, we wanted to help increase the accuracy of this. So we did, using the Bayes rule and probabilities, we're able to change that answer. And this is by taking a look at how accurate these voters, these labelers are prior to this, and then take that into consideration as well. So now in this case, with the Bayes rule and probabilities, we're seeing that the actual answer here is a Shar-Pei. And even though majority voting, 3 of the 4 voters actually voted bulldog, Shar-Pei becomes the answer over here, right? So this is taking advantage of something known as expectation maximization. We're using a modified version of this algorithm proposed by David and Skeen internally here for ground truth. I've linked the literature here, and I'll have my email out in the end. If you want a copy of these slides, feel free to ask, or you want to take a look at the literature here, how we do that expectation maximization. Feel free to check out that link as well. So now
I'll post a link to the slides on that calendar. So
perfect.
Thank you. Yeah.
Yep. Now, the next thing here is we do active learning and auto labeling to help bring down that cost of labeling large data sets. So you can see in this slide over here on the left, you have your input data sets. In this case, you can see it's a photo of a dog. We're going to send that to our labelers, plus do that annotation consolidation that we just saw before. And then we get these outputs, which is, in this case, drawing a bounding box around the dog, right? So these data labelers are just showcasing where the dog is in the photo by drawing bounding boxes around it. And this is great. This will get you your data set. This will be, it might be costly if you have a large data set. So with active learning and auto labeling, what we do here is after you've trained, you've labeled 1,000 pieces of data, from there, we'll start training a model. And then we're going to start sending that data to the model rather than the human labelers. And this will give considerable cost savings over here. However, if that accuracy of that model response is low, then we're not going to use that model response, and we're going to again send it back to the human labelers. And then from there, that'll go again in the labeled data set, and after we'll keep retraining that model until the accuracy starts increasing. And then over time, we're going to start seeing that more of the data is being annotated by that model versus the human labelers. And then you've considerably reduced the cost for labeling your large data set, as well as you still get to keep that model as well in case you want to use that in the future too. So that's
the question. There was one question, Kunal. So in terms of the percentage of accuracy a Mechanical Turk provides for non-sensitive data labeling, is there some statistical data you have there?
So Mechanical Turk is a group of labelers, right? I'm not sure of the question for what specific use case or what type of accuracy the question was asking for.
Say the example you gave just now of using Mechanical Turk to do labeling. Yeah, this one.
Right.
So when you have these human labelers and you use Mechanical Turk for that purpose, statistically, in terms of what you've seen so far, is there some accuracy percentage?
I think so. That's an abstract question. It depends on the use case. It depends on the type you're getting labeled. For example, I showcased in the beginning garage door open or close, right? Very simplistic use case, very high accuracy. Something more complex, it'll be maybe a little lower accuracy, the more complex the task. And then if something requires high subject matter expertise, you're going to see lower accuracy with Mechanical Turk. And then you're going to start seeing higher accuracy with people who have more expertise in that specific thing. And so it's kind of a spectrum there.
Feedback loop, this active learning feedback loop that improves the accuracy.
So this is different. So the feedback loop will increase the model itself, the accuracy of the model. And then you can set how accurate of a result do you want from the model before you accept that model versus taking it from the human annotators.
Perfect. Thank you.
So that was that ground truth tool that we have in SageMaker. Now, the next couple of tools that we have here, these are tools that we've just released.
sorry, if you go back to the previous slide, there's another question. And I just want to make sure that people are following along. So they want to know in what exactly does the computer vision, what does that do? I mean, how does it do auto labeling?
Yeah, so good question. So essentially what you're doing right now is you are training a computer vision model, right? So basically what those human annotators are doing, you're teaching a model to learn from what they're doing and what they've done before, so the computer model can replicate that. In this case over here in this slide, the annotators are just showcasing where that dog is in the photo by drawing a bounding box around the dog. Mm-hmm. After multiple sets of that labeled data, the model is actually learning itself how to detect where that dog is using other object detection algorithms. And then from there, it's going to start using that model to label your data versus using the annotators.
Got it. Thanks.
Yep. Yeah, and also feel free to email me out in the end, or if you want to set more time to talk about any of these services as well, just in case I can't get to a question over here. I also will be giving, towards the end of this, credits. If anyone wants to play around with any of these services, again, feel free to email me and I will give out credits to everyone too.
Awesome, thanks.
Or you can just ask Prakash as well and I'll send it to him and he can pass that on. Okay, so the next set of SageMaker tools that I'm going to be speaking about today, this is something that we launched at our previous reInvent last year, December. And this is our SageMaker Studio tool. And essentially the idea here is that with typical developers, we tend to use IDEs for building our code and debugging our code and monitoring our code. And that typically wasn't there for that machine learning experience. So this is something that we launched and we released last December. And I just want to showcase some of those things over here for debugging, monitoring, and then also helping out with that machine learning journey, right? So I think I mentioned before, again, this is a really iterative process where it's not linear. You have to go, you have to make sure that we're choosing the best hyperparameters, the best models, the best algorithms to train our model. So in this case, I'll showcase another tool we have here that's called Autopilot. And then I believe Shashank will talk a little bit more in depth about that as well after this. Okay, so SageMaker Studio is that IDE that we launched last December. And you're taking a look at how that looks. So over here on the left-hand side, you're seeing something called, it's tracking all of your experiments. You're seeing that under the objective column on the left. And don't worry if you can't see this right now, I'll showcase this live as well. But you're seeing like the accuracy of the models. You can look at this in different ways of how everything you're working on. You can visualize it in charts. On the right-hand side, you can see your code and then walk through that process as well. And if this looks familiar, this was built on software known as Jupyter Labs. So it's definitely very familiar to a lot of people. So let's start diving a little deeper into this. One of the first things that we created here with SageMaker Studio was the ability to track your experiments in one place. And the idea here is that machine learning process, it creates a lot of artifacts that are hard to track. And with the SageMaker experiments, we want to make sure that we can put that together for easy comparisons, visualizations. You can organize it, rank it, sort it based on a chosen metric, and I'll showcase that in a bit as well. Now, another thing here is reproducibility, right? So all your code is in notebooks, and prior to SageMaker Studio, it took a little bit for you to first launch a notebook and a notebook instance. So it took about like 5 minutes to launch a notebook instance and create your notebook and then start working in that. Now with this new SageMaker Studio IDE, it can happen in less than 30 seconds. And also we wanted to simplify that sharing process as well. A lot of our customers told us that was also a hard problem. So I want to showcase this. So I'm going to end my presentation just temporarily, and I'm just going to switch over to my browser. Let me know if there's any issues and you can't see anything. And so this is our IDE over here. It's called SageMaker Studio. And I want to showcase this notebook functionality right now. So you can see In the beginning, we have this welcome to Amazon SageMaker Studio. There's 4 options over here. I'm just going to click on create a notebook. And when we create a notebook, that's it, really easy. It just asks us what type of kernel do we want in this case, right? So do we want our data science tools built into it? Do we want it optimized for MXNet, PyTorch, TensorFlow, or no kernel whatsoever? So right now, we can just say data science and say select, and it'll go ahead and just spin up a notebook for us. And then once we have that notebook, so let me just pick one over here. And now we have our notebook, we have our output here of this notebook, and we want to share it with a colleague to showcase some of the results we have. Right away, all we need to do is click on this share button in the right-hand side over here. As soon as we click that, we're going to get this option over here. Do you want to include any of the Git repo information that you've included in your notebook? I'll say yes. Do you want to include the output? I'll say yes. Then we say create, and now all of the dependencies, everything that notebook is using is all packaged up over here, and we can copy that link and send it to our colleague. And then from there, they can go ahead and load up this notebook and have the ability to reproduce and see any of the results we created. So that's one of the things that we've made easier with notebooks. So let me go ahead and go back here, showcase notebooks. Now, another thing over here is debugger, right? So again, this is a common thing for normal developers with their IDEs. And basically with machine learning developers, we historically haven't had good visibility into our training process. And as a result, it's been challenging to ensure that the model has always been progressively learning the correct values for the correct parameters. And with debugger, we want to help solve that. So one of the things over here is, for example, if let's say our model gradients are getting too low or they're getting too high, debugger can alert us to that. So for example, let's say we are suffering with vanishing gradients. Then we'll get notified, and then with a little brainstorming, we can start kind of exploring ways to solve this. Maybe the neural network is too deep, maybe our learning rate's too small. We now have information to help us move forward from this. And then again, I just want to showcase this. This is not a linear journey to building this model. It is iterative, many steps over here, and a lot of it is going back and forth to make sure that we have the best model possible for our use case. And again, this is because there's many different types of algorithms, many different types of ways we can change our parameters for that to optimize them for our model. So we introduced a service part of SageMaker in this last re:Invent called Autopilot. And Autopilot is very interesting. You don't need to have much machine learning expertise or any at all, and I'll showcase this. Essentially, all you need to do is just provide your data in a tabular format. So right now, this is only for tabular data. And once you give that to SageMaker Autopilot, you specify your prediction target. Which column do you want to make sure you can predict on when you get a new row of data? And then from there, it does everything else. It'll choose whether this is what type of model this is. This is a classification or regression. It'll automatically do the feature engineering for you. It'll do all of the hyperparameter optimization for you. And this is all integrated, right? So it'll take care of all of this. So I'm going to go ahead and just showcase an example of this really quickly. So this is some tabular data I have over here in Excel. And this is just showcasing churn, right? So this was an open data set and showcasing churn based on some, I believe, mobile service. From here, you can see certain features of this data for each customer. Each row represents a customer here. And you can see that how long the account holder has been there, the area code, the number of minutes they've spoken, how many times did they get in touch with customer service, and whether they have churned or not. Have they left the service or not, right? So I have this data set right now, and I want to be able to predict in the future, if I know all these other pieces of data here, can we figure out whether, or predict whether they're going to churn or not, right? So with Autopilot, I don't need to know anything else. I have this data. I want to be able to predict on this column churn. And then let's just see how that works. So I'm going to go to my browser. I'm going to go back into SageMaker Studio. Again, we're coming back in the same tab we were at earlier where it said create a notebook. Now we're going to click on this one over here, create an autopilot experiment. And just like we're going to give it a name, let's call this name churn ATEA sample. And then from here, we're just going to give it where that tabular data is. And I've already uploaded it to a bucket of mine. And this is called churn.text. So that's that data set we just showcased. Now we want to predict on the column called churn. So that is, if I scroll up here, that's this column named churn. And I want to say, where do you want this? It's asking for where do you want the output to be? I'm going to say, put it in that same bucket we have. Everything else will be taken care of for us. So I'm going to click on this bottom right where it says create experiment. And then from there, it's going to start now analyzing our data. It's going to start doing the feature engineering to see which features make sense of that data to help the predictions. It's going to do an exhaustive search of multiple models to see which gives that best result, and it's going to showcase that for us. So I've already done this in the past, and now you can see that exhaustive search done for us, and you can see the accuracy of these models as well, and we can sort by this too. And so Shashank will go deeper into this. I don't want to spend more time on this, but it's something that I think you definitely take time and play around with this. It's definitely an interesting feature that we released here. So again, quickly how it works, it'll analyze your data set, it'll calculate the statistics and determine all the different combinations it needs to look at. From there, it's going to create 2 of these notebooks. You can see buttons for these notebooks as well. And this will just go over 2 things. The data exploration notebook will tell you what it saw in that data that's significant. And then the candidate generation notebook is telling you what process it's going to use and the decisions it's going to make to start experimenting with different models. And you can use that to understand some of the decisions it made to start training those models. And again, it's simple to get started, like I showcased. 2 different notebooks here. One thing to note, just going by how accurate that model is, it might not necessarily be the right answer. You can see latency is a big thing too. We want that speed and result as well. And just by lowering 2 percentage of accuracy over here, you can see you get much faster latency. So depending on your use case, this definitely changes based on which model you chose, right? Again, I have that very simplistic model in the beginning of this presentation, garage door open or closed. That highly accurate model is not necessary for me to get great results from that just because it's quick and simple and it's 2 different choices there. So depending on your use case, you might not necessarily need the highest accuracy model. So another thing we have over here is Model Monitor. And essentially with Model Monitor, you want to be able to detect drift in your models. So this is changes in real life data that's being sent to your models for inferences on. And Model Monitor is pretty interesting. To get that drift detection, essentially what it's doing is it's taking a look at all of the data being sent to your model for prediction, and it's recording that. And it's also recording the output that it's giving as well. And then from there, it's comparing it to the baseline of the data you trained your model with and the outputs that came from that training data. And it's checking to see any deviations. And then from there, based on that, it'll alert you, letting you know, hey, there are deviations happening with data coming into your model. And then from there, you can take a look at that data. You can start seeing, okay, real life data is changing from what my model was built for. Let me use this recorded data and retrain that model, or take whatever action you want to take based on that to make sure your model is always giving the best results for that use case. So that's called Model Monitor. So now we move into that top level of services, and these are our AI services. Again, these are for any developer, whether you have machine learning expertise or you don't. These are APIs that you can take advantage of. I'm going to just be going through a subset of some of these services here. One that I want to point out that I don't have a slide for is called Amazon Code Guru. This is something we just recently launched. It's actually really interesting. It does automated code reviews for you based on machine learning. would love to talk a little bit more about that. I don't have a slide in this presentation for it. There's some great YouTube videos on that as well. And if you're interested in more about that, just reach out to me and I can send more information on that too. So again, these services are just APIs that any developers can use. And so the first over here that I want to showcase is called Amazon Polly. This is our service for text to speech. Now, this slide here showcases audio. I'm going to put my audio up, but I think it's going to sound faint. I apologize for that. What I'm trying to showcase here is just how easy it is to create that text to speech audio. So let me just showcase that really quickly. So the first thing here is it's very natural sounding. And I'm going to just be quiet here and just hopefully you can hear this.
Alice was beginning to get very tired of sitting by her sister on the bank and of having nothing to do. Once or twice she had peeked into the book her sister was reading, but it had no pictures or conversations in it.
So I apologize if that was really faint, but essentially what we're trying to showcase here is that's just natural sounding audio. The other thing here is with Amazon Polly is it's accurate in the way it processes text. So in this sentence over here, today in Las Vegas, Nevada, it's 90 degrees Fahrenheit. There's an abbreviation, 90 degrees Fahrenheit. It's able to pick that up.
Today in Las Vegas, Nevada, it's 90 degrees Fahrenheit.
So it was able to pick that up accurately. And the next thing here, we live for the music live from the Madison Square Garden. So live and live, it's able to distinguish that based on the context of the text.
Today in Las Vegas, Nevada, it's 90 degrees Fahrenheit.
And then it's hard to confuse it with tongue twisters.
We live for the music, live from the Madison Square.
Wait,
So
Kunal is going one behind. So when just now it showed the we live for the music.
I see. Okay. Did you see the Peter Piper?
No, not yet. No, we did not.
Did it go now? I feel like mine's a little accelerated.
That's okay.
Okay, so essentially the idea is that it's thank you. But the idea is that you can't trip it up. It's able to pronounce that text very clearly, and it's great to use for any sort of audio interface that you might need to add into your application.
Mm-hmm.
The other thing here is Comprehend. So Amazon Comprehend is our natural language understanding service here. In this case, we have a domain of that called Comprehend Medical that I'm showcasing. In the slide, you can see doctor notes. You can see it's abbreviated. Patient is 40-year-old mother, software engineer. You can see medications. You can see a lot of information over here. And with Comprehend Medical, it just makes it easy to understand what's happening for your applications. So for example, this is what we typed into Comprehend Medical just from doctor notes, and this is what it understands. Right away, it picks up 40YO is the age and also understands that this is protected health information. Profession, it gets right away. It understands the medical condition. It picks up the different medications. It picks up the different medications as well. It also understands the anatomy of what's happening too. The next thing is it also picks up the dosages and the routes and the frequencies to take those dosages as well, all from this body of text. So Comprehend Medical is doing that natural language processing, in this case, not only for regular text, also for that medical domain too. And again, this is all an API. This is something you can take advantage of without any machine learning expertise. Now we have another service here called Amazon Recognition. And now this is a service near and dear to my heart. It's based on computer vision. It makes it, it definitely simplifies that process. I'm just gonna just showcase that really quickly over here. So if I go to recognition, this is our console for recognition. Essentially what this page is showing you is that you can give it a photo and it'll tell you what it sees in that photo. This is a person, these are cars, it's drawing bounding boxes around those objects that it sees. So it's object and scene detection. Now, this is great for the categories it already has built into this model. But let's say you have something that it doesn't already know or know what it is. That's where custom labels for recognition comes in. In this case, you can provide it photos of different types of objects and then you can start classifying, labeling them, and it'll automatically understand what those are as well. So in the beginning, when I gave, again, that simplistic example, garage door open or closed, I actually built that using SageMaker, but now you don't need to do that. You can just bring a bunch of photos of the garage door open, a bunch of photos of the garage door closed. It'll take care of all the machine learning for you, and then you can take advantage of that as an API for your own specific use cases as well. In this case over here, I think we're showcasing car parts as well as food, corn in this case, for the slide. Now, personalize is another interesting one over here. This takes advantage of a lot of the learnings we've had here, specifically for Amazon.com, for providing that recommendations for our customers. Basically, you provide an activity stream of your application, clicks, page views, signups, purchases, as well as any inventory of items you want to recommend, for example, articles, products, videos, etc. And then personalize will go ahead and examine that data, identify what is meaningful, select the right algorithms, and train and optimize a personalization model for your data so you can generate real-time recommendations. It's actually taking advantage of a lot of that same aspects we have for autopilot as well, doing a lot of that machine learning in the background for you. Just two more services here I want to just showcase. We introduced Amazon Kendra, which is our enterprise search service. This takes advantage of natural language, again, understanding, so you can use natural language just to search your data. And for your data, you can connect multiple different types of data sources to search on. So for example, in this case, you can take advantage of your S3 buckets, and there's a lot of other connectors over here. And we'll have a lot more of these popping up as well in time. But basically, you can kind of connect all these different silos that you might have in your organization and just start searching for it, and with kind of everything done for you in the background. This is a default interface for how this looks. Again, you can see over here, we have this question, when is reInvent? Just basically, you can ask the question as if you would talk to someone else. From there, Kendra will understand what you are trying to search for. It'll give you a suggested answer. It'll give you some other frequently asked questions. And then from there, you could go ahead and choose, you can see the actual search results. And from there, you can kind of start training it by clicking on the thumbs up, thumbs down buttons over there and letting it know how accurate it gave that as well. So if you do want to learn more, we have over 45 hours of training materials and over 30 courses to take advantage of. Basically, you can go to aws.training/machine learning. The other thing I want to showcase here is a lot of the stuff I was playing around with, a lot of those services I mentioned, we have great examples and tutorials. So if you want to play around with any of those, I just put it in this bit.ly link over here. Basically, bit.ly/AWS-SageMaker-examples. This is a great resource to learn more and just see how things are done. And from there, if you want to experiment with it, feel free to. Last thing, for this presentation, anyone here, I'm giving out $50 credits for your AWS console if you want to play around with any of these services. So I have my email there, kbatra@amazon.com. Feel free to reach out to me for a couple of things. If you have any questions on any of the services you want to play around with it more, or you just want the credits, kbatra@amazon.com, or feel free to reach out to Prakash. You can just get in touch with me, whatever that may be. And then I will also be sending these slides to Prakash as well. And then my Twitter handle @Kunal732, by far the fastest way to reach out to me to get the fastest response. And that's it for me. Thank you for letting me present these services.
Awesome. Thank you, Kunal. So there have been questions, and Shashank has been really good about answering those questions. And I think that is a much more efficient way to go through these. So hopefully people are seeing their responses in near real time. So Kunal, I'm going to request that you do the same so that Shashank can complete his presentation. So folks, we'll be taking another 45 minutes or so please plan accordingly. You're going to see another awesome presentation from Shashank. He's going to be talking about AutoML. So Shashank, I'm going to make you the presenter. So you're presenter now, Shashank, so you should be able to go. Share your screen.
All right. Let me know if you can see my slides.
Yes, we can.
Okay, and yeah, maybe not 45 minutes. I'll probably take something shorter, so
okay.
Your Saturday back. All right. So, hi, I'm Shashank, and this is what I looked like a few months ago, minus a few hairs today. Um, Vanakkam en per Shashank. That's all the Tamil I know. Um, and today I want to talk about AutoML. I'm sure you've heard of AutoML. There's a lot of hype around it. A lot of definitions online that all differ from each other in different aspects. I want to talk about what they are, and I'll talk about two capabilities that um, fall in the AutoML category that you can use and get started today. I'll quickly recap what is machine learning. Many of you may be familiar with it, some of you are new to it. I'll just talk about what is machine learning and some challenges associated with it and how AutoML solves it. And I'll introduce two capabilities. One is an open source library called AutoGluon, the white box on the right here, and one is called Amazon SageMaker Autopilot, which Kunal mentioned, which is a managed service. So I'll talk about both of these two things. And finally, I'll be showing demos for both of these services. If you're familiar with Kaggle competitions, which is a popular data science competition platform, much like what's that, top coder and few other things for software, right? So I'll show you how you can actually compete in one of these competitions and get top scores with almost no machine learning expertise. All you have to do is just provide your data set and you can get top scores in some of these competitions. Okay, yeah, some exciting stuff. So let's get started. So you may already be familiar with machine learning, so this may serve as a quick recap. But before machine learning, right, if you have to do things like, recommendation engines or sentiment analysis or, generate forecasts or things like that, you would generally do rule-based things like, hey, did you buy this product? Then here's another product that you may like. Or, hey, does the sentence have certain negative sounding words? Then maybe it's a negative connotation. There's negative connotation, right? Or in some cases, you knew formulas, right? Physics. You would write formulas to Newton's laws of motion or things like that. So either you generated handwritten rules or you had like first principles based formulas from the phenomena itself. But a lot of applications, especially in like perception based applications like computer vision or language understanding, text to speech, object detection, those sorts of things, you can't write handwritten programs because they're all pixel values and it's really hard, and there are no first principles equations. And this is where machine learning algorithms come can take your input data and map them to your output data, and it works great. I mean, there's a lot of applications out there today that we interact with that use machine learning, and it works great. So what's the challenge, right? Well, the challenge is that there are like hundreds of different algorithms to choose from, uh, at least tens of them that are really good. So what do you choose and how do you get started? And this is just one half of the challenge. If you take a look at the entire workflow, it's more nuanced than just, hey, let me train a model on my data set, right? There's the data collection, there's a data transformation, there's feature engineering where you look at the data and try to come up with features that could be a better suited for training the model, then selecting one of the tens of models that are algorithms that are available, but then they don't work out well out of the box. You have to tune them using hyperparameter optimization techniques, and then you train and evaluate, and then you deploy, right? Once you have your model. So the problem is that not you may if you're not a machine learning expert or a data scientist or have spent time doing this, a lot of these intermediate boxes can be challenging, and this is what AutoML is, the general field of AutoML is trying to achieve, is to take all the codify all the best practices from the industry, from expert data scientists or expert knowledge in the community, and see if you can package it up into a software or an API or a service that will do all of these steps. You're still responsible for bringing in your data sets. You're still responsible for hosting your models once you train them. But a lot of the model building process can be uh, automated with AutoML packages. Great. But if you Google AutoML, you will see, I almost guarantee you won't see two definitions that agree with each other. A lot of companies and tools refer to AutoML to do different things. In traditional machine learning, there are tools that will combine feature selection and model selection and call it AutoML. Some tools will do model ensembling, which is like combining multiple models to give you better results and call it AutoML. Some tools will do just hyperparameter optimization, which are parameters that you set in a model before you train them. Maybe it is, what kind of learning rate do you want or things like that. And they call it AutoML. And in deep learning, similarly, some tools will do hyperparameter optimizations and call it AutoML. Some will do network architecture search, which is how to find the best model architecture for your model. And some will do model ensembling. And for each of these capabilities, there are different ways to achieve the results. You can do exhaustive search, or you can use heuristics. You can stack your models. You can combine your models in different ways. You can do grid search, which is exhaustive. You can do random search for hyperparameters, or use sophisticated techniques like Bayesian optimization. For network architecture search, there are all these other techniques like reinforcement learning, PNAS, ENAS, DARTs, and something else that'll come out tomorrow. It's sort of crazy out there. There are so many different techniques, and it's really hard to stay up to date with all of these different uh, uh, community-driven sort of efforts. So, in the rest of today's presentation, I want to talk about two such capabilities that we at Amazon use and have made available. One is called SageMaker Autopilot, which you got a glimpse of from Kunal's presentation. And the second is called AutoGluon, which is an open source library that Amazon released December of last year. And this is completely open source. You can go download it, install it on your laptop, and get started. SageMaker Autopilot is a managed service, which means you log into your console and then you walk through the process of generating your models automatically. I've put links to both of these below, and I'll share these as well at the end of the presentation. So, brief introduction to SageMaker Autopilot. As Kunal mentioned, it's part of the broader umbrella of SageMaker suite of capabilities. The whole idea of SageMaker is to have a capability for every aspect of the machine learning workflow, whether it is authoring your code, whether it is managing experiments or debugging your code, or automating it with autopilot, or hosting your models. There's a capability for each of these. And way at the bottom, one of the capabilities under SageMaker umbrella is autopilot. And this is what I'll be covering in this section. And very briefly, again, this is a little bit of a repetition from what Kunal said. You provide your data set, you specify what type of problem this is, or in many cases, it'll infer from your data set what kind of problem it is. And rest everything is taken care of for you. It'll generate a model, it'll track your experiments. And the best part is it'll actually automatically generate the code that it used to generate the best model. The advantage of this is now it's transparent. It's not a black box. It's not where you provide your data set and give you a model and won't tell you what it did. It actually generates the source code for you, which means you can take a look at your generated source code in a Jupyter notebook and tweak it and try different options from that. So you're learning as you go along, not just relying on a black box to do all the work for you. So very briefly, again, this was covered. Candidate generations, it'll take a look at your data, generate your candidates, take a look at your problem, generate automatic notebooks, and it'll automatically spawn a large number of workers to try different options in parallel. And under the hood, imagine if you want to try 100 different, if Autopilot wants to try 100 different options, right, different models and hyperparameters, you need access to infrastructure. You need to be able to run these on different instances and scale, but all of this is taken care of under the hood. If you were to do this yourself, you'd have to figure out a way to provision instances on the cloud, go run different copies of the software. None of that. It's all automatically managed for you. Okay, so let's take a quick look at a quick demo. In this demo, the fun part is you can do everything without writing a single line of code. But as with many AWS services, you can do the same things that you do on a user interface using the API. You can use a CLI on the command line. You can use, if you're a Python user, you can use the Boto3 API. If you're a user of another language, we have APIs for multiple languages like JavaScript and .NET and few others. So you can do this using your favorite language if you do like to perform these steps programmatically rather than user interface. But we find that a lot of expert users also like the UI because it'll help them be more productive. Okay, so with this, I'll quickly jump into demo. And very briefly, if you're new to SageMaker, if you've never seen SageMaker, once you log into the console, you'll see these different options available to you. Kunal briefly mentioned them. There's labeling, there's an authoring capability with notebooks where you write your code and stuff like that. Training, you get managed training instances. If you want to train something on 52 GPUs or 64 GPUs, you don't have to manage infrastructure. It'll automatically take care. Then inference deployment, hosting your model endpoints for consuming client side, maybe on a mobile device or an app. And there are plenty of algorithms in the marketplace. But what I'll focus on right now is autopilot. And this is the SageMaker Studio that you just saw. It's a IDE of sorts for machine learning development. Now, if you want to start training autopilot job, it's easy to do this using UI. So you just hit create experiment. You can select job name, and you can specify where your data set is. So in my case, I have a tabular data set, and I'll briefly show you what it looks like as soon as I select it. So I'm going to select a tabular data set, automl.train. So to show you what that looks like, autopilot, I have a notebook here where I show you a glimpse of what the data set looks like. So I have a data set, this is called bank marketing data set. Essentially, it's a bunch of information about people, customers, bank customers mainly, whether they were married or what kind of education they have. And at the very end on the corner is a target variable, which is my output, is whether they're marketable or no. So yes or no. It's a binary classification problem. So all I did was I took this data set, I uploaded it to Amazon S3. Again, if you're new to AWS, Amazon S3 is an object store. You can use Amazon S3 to store not just your data sets, but whatever you want, training metadata, people host websites there. It's a highly scalable object store. So I upload this to Amazon S3, and once I upload it, I just provide a path to it in this user interface, and then I specify what my target variable is, which is y. In this case, you see here on the right, the target variable y. And once I do that, I can specify where I want it to dump my results. Again, I can specify a custom path if I want. You can customize this however you want. And we'll zoom into this aspect here. You'll see here that autopilot can automatically infer what kind of problem it is. It can infer whether it's it can automatically infer from the problem, or whether it's a binary classification where you're classifying discrete categories, regression where you're predicting continuous values, or multi-class. And in this case, I'll say let's automatically choose. And also you can ask it to generate notebooks, as I mentioned. So if you click create at the bottom right, it'll start off a job. Now I won't make you watch as the job trains. What I'll do instead is show you a job that I just started before this call. So on the left, under the experiments tab, you can see all the jobs that were see a job that I already trained with autopilot, and each of these entries here is actually a separate training job that autopilot trained. So it tried different combinations, and as I mentioned, this is not black box. So yes, it trained all of these for you. It even provided you with the objective value. You can sort them and see what is the best model. But if you really want to see, so right up top here, you can see that it's providing me with the best tuning job. So this is the best job with the best accuracy, all with a few clicks. If you really want to see what was done behind the scenes, on the top right, you can see here there are two buttons. One of them is candidate generation, the other is data exploration. Let me click on the candidate generation notebook, and you'll see here that this notebook was automatically generated for you. So what does this contain? It contains all the steps Autopilot did in order to get there. So you actually can take this notebook and tweak it and do different things yourself. If you are savvy and if you know if you're familiar with machine learning but you want to tweak things, you can do that, absolutely. And there are some helpful hints as well. To show you a quick example, you'll see here that uh, let me increase the zoom a little bit so it's clearer. You'll see here that there's one model which was using XGBoost, which is a popular machine learning algorithm. And if you scroll down, you'll see um, another model which uses the same algorithm with different pre-processing steps. And you keep scrolling down, you'll see that it's tried all these different combinations, all these different data pre-processing steps, and it even explains what it is doing, whether it imputes missing values, which is replacing missing values with another value, or completely removing missing values, and so on. So this notebook is available for you, and in many cases, you don't even have to run the full training job. You can just ask Autopilot to generate these notebooks, and you can train selective algorithms from that notebook. You don't have to train all of the algorithms. And once you've trained your best model, you can deploy it right from this console. You can click this deploy button here, and it'll present you with an option to create an endpoint. You can say test endpoint. You can specify the type of instance. If you have a pretty complex model, you want to give it a more beefier compute instance. So these are basically EC2 instances with different CPU and RAM and other characteristics. So you can take something lightweight, or you can deploy to something heavyweight, large number of CPU cores. It depends on the type of model that you're training. You can specify how many instances you want, and SageMaker will automatically load balance traffic. For example, you deploy a model, you have 100 customers today, but tomorrow you get 1 million customers, right? You want to be able to scale up or scale out, right? You want to be able to uh, manage all that traffic, and SageMaker will manage it for you. You can specify more number of instances here. It'll figure out load balancing and all that. You can also do things like A/B testing on the endpoint. And deploying the model is just as easy. You just hit deploy and it'll start creating a model. And if you want to take a look at where it's deployed, you can always go back to the console, and you can see endpoints on the left here, and you'll see that there's an endpoint being created. You can monitor all these SageMaker activities, such as training and notebooks and endpoints, right from the dashboard as well, right here, or by going to these specific sections. So I'm running 4 training jobs. I'm running a hyperparameter tuning job. I'm not doing it. Autopilot is doing it for me. I have 2 endpoints and stuff like that. You can always monitor status of everything right here. So that's a quick overview of Autopilot. Today, it only supports tabular data, which means your data should be from a spreadsheet or a database and look something like this. If you have images or videos, you can't use Autopilot. But I'll talk about the next capability, the open source AutoGluon library, which can handle other data formats. So let me jump to the next example. So the second package I want to talk about is AutoGluon. It's an open source AutoML library. And this you can download and install it on your laptop, try it out right now, right after the call. And there are just 3 functions where you can do end-to-end machine learning for tabular prediction, but also for image classification, text classification, and object detection. And I'll show you at the end of this demo how to submit results to a Kaggle competition and get top scores with just these 3 function calls. That's all you have to do. Point it to a data set, ask it to fit the model, and generate predictions. So let's take a look at what this is and how it works. So everything I'm going to show right now is things that you don't have to know. It's what's under the hood. But for you as a user, all you need to know is how to use the auto glue on function. So you'll just provide your data set and say fit, and it does everything under the hood. So whatever I'm going to show you now is just FYI, um, good to know, right? So there are things that it does under the hood. One is it automatically data pre-processes. So it'll take a look at your data set, whether it's a tabular or something else, and it'll automatically do feature engineering for you, remove things that are not useful. It'll automatically transform text columns into numeric vectors and so on. And it'll explore a number of machine learning algorithms. It'll run through random forests, randomized trees, nearest neighbors. These are all popular machine learning algorithms. It'll run through all of them and generate an ensemble, not just pick the best one, but combine all of these to generate very good results. And it also includes deep neural networks with a custom architecture that was designed by our science team at Amazon that works really well, which is why you get award-winning scores with these. And again, you don't have to know all of these. All of this is done for you when you call the fit function. And other novel things that it includes are things like ensembling and stacking. Uh, it does all of this under the hood for you. It'll actually combine the power of all these models rather than just picking the best one. It's also performance optimized. I ran a demo on a 96 core CPU machine, and you'll see it utilizes most of the cores, almost 85%. So you can easily throw in more compute and train models faster with AutoGluon. And now I want to show you a demo. So if you're not familiar with Kaggle, it's a data science competition platform. World's expert data scientists go there to compete. Many of the competitions have prize money associated with them. This particular competition had $10,000 when it was running, but there are competitions that offer you like millions, I think. So a lot of expert data scientists go to these and solve problems. What I want to show you is how you can compete in one such competition. And what you see on the right is all of the code that you need, where the crux of the code being this fit function to get top 1% score in a competition like this. Of course, the competition is over right now, so I can't submit results, but I can generate the scores and compare my place in the leaderboard. And you can get top scores with just this whatever code you see here on the screen. So let me jump into a demo, and back to my studio notebook where I'm running the demo, but you don't have to do it here. Let me switch to something light so it's easier to see. Okay, so again, all of this is open source. I have code available on GitHub if you want to take a look. And what I'll do here is just briefly walk you through the steps that was needed to generate results. So this is start to finish, everything from downloading the dataset to submitting results to Kaggle in one small notebook. So you start by importing AutoGluon, and I'm importing tabular task because this is a tabular prediction, but you can also import image classification, object detection, or text classification. And once you do that, I use a Kaggle's API to download my data set. And once I've downloaded my data set, I can take a look at my data set. This is what the data set looks like for this particular problem. There are 93 features and a multi-class classification. It's a multi-class classification problem. And the crux of my effort goes into writing this fit function. So I just provide my data set and I specify the metric, and that's it. AutoGluon will then go through your problem. It'll determine how many classes are there, what kind of problem it is, train all these different models, combine all these different models, and finally generate a model that it thinks performs best. And after that, all I have to do is upload this model to Kaggle. I generate probabilities, which is the predictions for my model. And then all I do is upload this into Kaggle. Now, what I'll do now is head over to Kaggle. Let's say, um, Kaggle auto classification challenge, right? So this is the challenge I was talking about. Let me open this in a browser where I have where I've logged into my Kaggle account, so I can show you the result that I submitted. So this is the auto classification challenge, and you'll see here that under my submissions, I have a couple of submissions here, and my score is 0.41. This competition is closed now, so I can't submit results, but 0.41 is my score, and I can go to the leaderboard. You'll see these are the top scores. So 0.41 would put me somewhere in the vicinity, zero point 0.4 in the vicinity of 30 or 33 sort of position amongst 3,500 teams, right? And I didn't have to do, if you look at some of these other submissions, they do a lot of work. They write hundreds and thousands of lines of code to get there, right? All I had to do was just submit uh, autoclue on results, and you can get top scores within sort of the top 1% with no effort. But you can tweak it and get better results out of autoglue as well. So that was a brief overview of what autoglue is. I'll start to wrap things up now. It's open source. Feel free to try it. I did a blog post earlier last month actually, on autoglue with more details about what it is, how it works, what are its key capabilities, those sorts of things. I put a link here, but you'll also get the slides so you can take a look at it. We also published a technical paper on this library where we compare AutoGluon to other leading AutoML solutions and show how AutoGluon comes up at top. We compare all the key popular AutoML solutions out there. So feel free to take a look. The paper is also linked in this blog post. You'll find it when you open up the blog post. All right, so that was my quick presentation. Didn't want to take too much of your time on Saturday. Again, I'm Shashank. I'm happy to answer questions. You can reach out to me on Twitter or LinkedIn. I also blog on Medium.com. So I blog about SageMaker, machine learning, bunch of things that I find developers struggle to do, and I try to write a blog post on how to solve that problem. I'm happy to answer questions now, but if you have questions tomorrow, a week later, a month later, please feel free to send them to me via one of these channels. I love answering questions, so that's part of what I do. I'll stop here. Thanks for listening.
So there were again, Kunal's been answering questions in the Q&A. There's just a couple more. So they want to look under the hood of AutoGluon and tune the parameters to get the best performance. So like an AutoML SageMaker notebook. So is that possible, Shashank?
You have flexibility with AutoGluon. You can. So what I showed you was a very high-level usage of the API. Let me pull up AutoGluon documentation. So you can use it out of the box, right? You can just say, if it's an image class, just say fit. It'll do everything for you. But if you go into the specific task, there are a lot of tweakable parameters. Even under fit, you can specify a list of algorithms that you want to tune. You can even pre-specify the hyperparameters. If you don't want to do that, AutoGluon can automatically tune it for you. The things that we find customers use and find beneficial are setting evaluation metrics. You can also set custom evaluation metrics. It has a great effect on the accuracy of your model, and stacking. So stacking is very, very novel to AutoGluon. You won't find this in a lot of packages out there. Stacking combines ensembles but stacks them on top of each other to really boost accuracy. And you can also have it automatically tune hyperparameters for you, but you don't have to. If you want, you can actually provide a predefined list of hyperparameters and models, and it'll train only those. So while the higher level API is completely easy to use and gives you out of the box accuracy, you can peel it open and do customizations. And the documentation has bunch of APIs that you can use to do this, like peel open and do specific changes.
Awesome.
Anything I can answer quickly that was open?
The one final question is on the Kaggle competition. So they're wondering if it's legal to use AutoGluon on and post on Kaggle.
I can't answer legal questions, but I don't see why not.
Yeah, okay.
It's just a tool, right?
Right.
You can use, I mean, Kaggle, you should read Kaggle's guidelines because that's the best source, but people use all sorts of tools to compete in Kaggle. Also, each competitor, so Kaggle is just a platform, right? The competitions are hosted by others.
Correct.
And they each will have their own guidelines.
Correct.
So I've seen competitions where they will have guidelines saying you have to only use open source tools, or they will say you have to use open source, but it should be certain license format. Because in many cases, they are hosting these competitions not for fun, but they want the results to be integrated into some sort of a bigger solution.
Right.
And to be able to integrate in sort of a bigger solution, they want certain restrictions. In any case, you should always check the competition itself, but it's hard to answer a general question like that. But check the competition specific guidelines.
Awesome. So again, folks, we had two awesome presentations from Kunal and Shashank today. I really appreciate them taking time off their schedules and spending time with us. It's been very instructive, and thank you both.
Thanks for having us.
Take care. Thanks, Shashank.
Yeah,
Bye.
thank you. Thanks, everyone. Bye.